All right, so page 83 was your homework, and it was just the front page, right? That's all it was, right? Okay, so let's take a look at them. I'll work them both. Well, we won't hand this one in today because there's more pages that come with it, and today's lecture will go along with it. But so we had a parabola, it looks like here. And it looks like 0, 0 worked out. So this was our parent function, right? So that's the thing that's going to get manipulated, moved, and all kinds of things. So let's, different colors. So problem number 1 says, hey, what happens with that? So it's grouped. So what does it mean? Does it shift right, left, up, or down? Or not shift at all? What do you think? Right, how many? Right 3? Cool. So this one will move it, all of our dots right 3. Okay, when it's grouped, it's always opposite. So from here, I'm going to go over 1, 2, 3. So this dot moved here. This dot's going to move over 3. 1, 2, 3. This dot will move over 3. 1, 2, 3. This dot will move over 3. 1, 2, 3. And this dot, 1, 2, 3. Okay, so the number 1 has a shift, a horizontal shift to the right of 3 units. Seem okay so far? Number 2 says, hey, we're going to do this. We have the f at x, and we're not going to group the minus 3 now. So if it's not grouped, does that change the direction it moves? Moves it down, right? So the red one we're still going to use as our basis. So all of the red points, I'm going to move down 3. All right, so this point here is going to move down 3. This point moves down 3. This one down 3. This one down 3. This one down 3. Okay? And again, we're looking at the red one as our original, and we're making the shifts from there. And then problem number 3, we have something grouped. So f at x plus 2 plus 3. So is this going to move in 2 directions, or is it still just moving 1? 2. So give me one of the directions it'll move. Left 2. Okay, because it's an addition, it goes opposite of what you think. So left 2 and up 3. Cool. All right, so off of the red one, again, we're using the red as our foundation. So we're going to go left 2, 1, 2, and then up 3. So can you see how this point moved? And then, let's see, this point, I'm going to go left 2, 1, 2, and up 3. This one as well. Left 2, up 3. Right, did I do that right? Wait, I moved too much, didn't I? Oh, I'm sorry. All right. So going from here, I'm going to go left 2, up 3. That was right. Okay. Left 2, up. Yeah, I was right. And I can't even graph any more points because it's going to go right off the grid. So from the red to the blue, I had to shift left 2 and up 3. And then number 5. F at negative x. So that means whatever x value I plugged in, I'm going to do the opposite of it right away. So here's the thing. This point doesn't shift. This point comes over here. This one comes over here. This one comes over here. This one comes over here. So I can't see it shifting with this one. So this one actually flips all y values to opposite. So if it was a positive Y value.
Isn't in our class.
Oh, she's not here. Not here today. Cool. So sometimes you can't always see the shifts that are taking place, even though it did take place. So that's the first. Well, did I skip a problem? Is it 1, 2? Oh, I forgot number 4, didn't I? Sheesh. All right, let's see. Let's do this dark purple. Number 4, we should have had this. F at, or 2 times f at x. This is going to double all y values. Okay, so this one stays here. This one comes up 2. It's got double it. This one would have gone up to 8. We're not going to see it. So red to the purple made it skinnier. It's got a vertical stretch. And then number 6. Number 6, I went out of order. Let's change colors on you. It looks like a nice, fun color. A little hot pink. Okay, number 6. Number 6 is going to go the negative f at x. So what this is going to do is it's going to change all of our y value. It's going to flip everything over, change y value, flip over. So this point's still here, but rather than writing up 1, this is going to go left, writing down 1, writing down 3. So flipped it upside down. So there's all kinds of transformations. And when I imagine when you'd have a quiz on this, I'm not going to throw 6 translations at you on it. I'll have one problem and you'll have to do one of the translations on the graph and then another. Because I know most of you have maybe 1 or 2 different colors. You might have a blue pen and a pencil, so it's kind of hard to mimic all that. But that's kind of pretty, but I'll take it. Cool. Questions? We're going to be working more with this. And then, let's see, number 7, they want us to do those translations again. So, math, graph, Cartesian. So 1, -2. So we'll make the pink our normal function. And so letter A, they want us to do this. So that's going to go up 2. So take all the points, go up 2. So that's our first transformation. It shifted up 2. Cool. Letter B says, ooh, we have the negative there. Let's see, letter B. So we're going to change all of our x values. So this one we'll actually be able to see. So remember, we're going off the purple one, right? Or the pink one. So this value here is actually here now. This value here goes to -2. This value here still stays right there because it's right on the axis. This value goes to -3. This value here goes to +1. So change all x values to opposite. So if it was positive, it becomes negative. If it's negative, it becomes positive. If it's 0, it stays the same. So it actually looks like it moved left, which, yes, it did, but the reason it moved left is because of those transformations. And then letter C gives us 2 things. So this is going to go left 3 and up 4. Okay. So going from the pink, I'm going to go left 3, up 4. I'm going to go left 3, up 4. Left 3, up 4. And I can't even do any more because it's off the grid. So shifting around side to side, back and forth, all those. So hang on to that sheet because there's more that we will work on with that later. So just a front side of notes today. That's all we got. So quick question. Can all quadratics, so ax squared plus bx plus c, can they all be factored? What do you think? If I had to say 2x squared plus 7x plus 15, does that have to factor? What do you think? Hello? We're only an hour behind. What do you think?
Yes.
Yes. So let's do this. Let's say we had 3x squared plus 7x plus 10. So does that factor? Does it have to factor? Well, let's see if it would factor. So remember this. We're going to go, okay, so we get 30. And both values have to be positive. And the factors of 30 are 1 and 30, 2 and 15, and 3 and 5. There's no other numbers. Or wait, 6 and 5, excuse me. 6 and 5, 3 and 10. And I think that's it. Those are all the ways I can get to 30, right? So is there any way I can make any of those factors add up to 7? No. So this doesn't factor. So that doesn't, not everything factors. Okay? It's still a parabola. We can still graph it, but if it doesn't factor, that means we can't see exactly where it would cross the x-axis. It could cross the x-axis, but not always. Yeah?
We didn't get a note.
Oh, shoot. I missed your whole row?
I just didn't ask that.
Big bum. I'll tell you. Sorry about that.
I wasn't paying attention.
No, it happens. All right, so let's just classify. Not all quadratics have to factor, but that doesn't mean that they don't cross the x-axis. Okay, and we're going to see once we get back from break, a formula that works nicely on it. But let's take a look at the very first one. We have this as our first given equation. So let's just list this. They tell us this is in standard form. They told us at top, right? So if it's ax squared plus bx plus c in that order, it's called standard form. Cool. And then it says, hey, we want to find the factored form. Okay, so I had negative 21. So I have positive and negative, 1 and 21, 3 and 7. Do either of those work to add up to negative 4? And if so, what has to make me negative?
7.
7's negative, okay? So that works, and that's negative, okay? And x squared minus 7x plus 3x minus 21. Agree? If I added those back together, I get my original. And then if I have this, that's x and x minus 7. And then what about this? That sign comes down. What do I factor out of both of those? Just a 3, isn't it? So I factor 3 out of 3x, I get x. Factor 3 out of negative 21, so I get negative 7. So what's my factored version? Yeah, x minus 7, x plus 3. Or x plus 3, x minus 7. Doesn't matter which way you do it. Okay? So that's my factored form. And then it says next to it, it says, hey, find the x-intercepts. Well, from this, I can find my x-intercepts. How? Yeah, so I can either look at it and say, well, it's both those opposite values, or I could take each and set them equal to 0 and solve. It's your choice. So that gives me 7. So that gives me the point 7 comma 0. That's a root x-intercept. And this is going to give me negative 3 if I subtract it. So I wind up with negative 3 comma 0. So these are my roots. I can see them. They exist on my graph. Okay, so if it did factor. If it factors, we can find the roots. Next says, hey, find the vertex. So there's 2 ways we can find the vertex. 2 ways I can find that vertex. So the vertex, we can do x equals negative b over 2a. B, and we know the roots. It happens in between. So if you don't know what number is between 7 and negative 3, then I'd say let's use negative b over 2a. And so with that known, my original was this. So that's my a value, which is 1. That's my b value, which is equal to negative 4. And my c value is equal to negative 21. Agree? So we use negative b over 2a. I'm going to go negative 4. That's a bad representation of two negatives, sorry. Over 2a, which is 1. What's negative 4? Positive 4. 4 over 2. 4 over 2 is equal to 2. So what is this, actually?
Your axis of symmetry.
Good. My axis of symmetry. We'll call it AOS. Okay. So then that's the x component of my vertex. How do I find the y component of my vertex?
Plug it in.
Plug it in. I can plug it into my factored version or my original. It doesn't really matter. So I'm going to take 2 and I'm going to plug it in right up here. So I get 2 squared, which is 4. Negative 4 times 2 is negative 8 minus 21. Let's see. 4 minus 8 is negative 4. Negative 4 minus 21 is negative 25. So that'd probably be way off the graph. Ooh, then the last step is, hey, what is the y-intercept? So that's 0, comma c. Okay, so my c value is what? Negative 21. Sweet.
Wait, how did you find the y-intercept?
So y-intercept is always 0, comma c. Or if we don't have it in that form, I could take that 0, that's an x value, plug it in here. 0 minus 7 and 0 plus 3. So I get negative 7 times 3 is negative 21. So multiple ways to get there.
So it's always c.
It's always c. If you can't see the c value, because it's like in factored form or it's in vertex form, plug 0 in for x, and whatever your answer comes out is your y-intercept every time. Okay? Did we answer everything on the standard form? So standard form is kind of like the basic. Here it is. There's things we can do. We can factor it. It doesn't always factor, but it's still a parabola. This one factored. We can find the vertex with negative b over 2a. If we know what the roots are because it's factored, we can find halfway in between it. The number halfway between 7 and negative 3 is indeed 2. So that's pretty cool. Everybody happy? Is that all right? Huh. Wow. Okay. May I move on?
Yeah.
So the next one says, we're giving you something that's already in factored form. So we're giving you factored form. We'll call that FF. And so they're saying that y is equal to 2, x minus 1, x plus 5. Okay? So those will find me my roots right now. My roots are being handed to me. Agree? Okay? So if we go and we graph this, I'm just going to draw it by hand. So this would happen at positive 1. And this is going to happen at negative 5. So I know my roots. If I know my roots, what happens halfway in between my roots? The axis of symmetry, and on the axis of symmetry is the vertex. So if I want to come halfway in, I'm going to come into negative 4 and 0, negative 3 and negative 1. Oh, it looks like at negative 2. At x equals negative 2, that's my axis of symmetry. So that's that line we could draw there if we wanted to, saying, hey, it's symmetric about it, but it's not the big deal. So what is the axis of symmetry good for? Where does it start to find us? It starts finding us the what? It starts finding us the vertex. So what's funny is they gave us factored form that says find factored form. That's the original problem, right?
It's on everyone.
Oh, okay. Find the x-intercepts. So if I want to find my x-intercepts, we found those. That's going to be at 1, 0 and at negative 5, 0. Okay, so they're given to us. And then we know that find the vertex. So I'm going to use negative 2 because of this. Where should I plug negative 2 in? Into x. Okay, we have to remember outside I have this 2, and then I have negative 2 minus 1 is negative 3. Agree? And negative 2 plus 5 is positive 3. So 2 times negative 3 times 3. So 3 times negative 3 is negative 9. Negative 9 times 2 is negative 18. Yikes. So that's like way down here. Let's just pretend. That's my vertex. Find the y-intercept. Well, the y-intercept is usually 0, c, but this is not in standard form. So what should I do to get my y component? Plug 0 into x. Originally I plugged negative 2 in, but I'm going to plug 0 in for x. So I have that 2, and then 0 minus 1 is negative 1. 0 plus 5 is 5. 2 times negative 1 is negative 2. Negative 2 times 5 is negative 10. And so that's like somewhere down here. I don't know. Let's just pretend we're... My graph is way off though, but I mean that's what my graph could start looking like. Did we answer all those questions there? Okay, so standard form provides us something to look at, something that could be factored. If it can't be factored, then we use our negative b over 2a, plug that back into x, get the y component of the vertex. Ooh, remember the pattern graphing? That's 1, 3, 5. Unless my a value, or in this case, it's not going to be 1, 3, 5, it's going to be 2, 6, 10 because that outside 2 modifies it. The first one I think would have graphed as 1, 3, 5. What do you think? Anything that we're not covering here? Those sweet shoes on, I like those. Fancy dancy. Cool, let's do that. Take a look at that very last one. Then they tell us, hey, we have vertex form. Now remember, vertex form is what we had been working on. And we learned a new concept, remember the other day, to complete the square? Remember that? So, but if they give it to you in vertex form, you don't have to complete the square to find it. So I get this, negative x minus 1 squared plus 4. Hey, does this parabola open up or down, and what tells me it does?
Down.
Down, why?
Because it's negative.
Negative out front. Good, good. So my pattern graph would be negative 1, negative 3, negative 5. Does anyone want to try and, let's see, what do we have? Find factored form. Ooh, find factored form. Well, no. Okay, let's try and find factored form. Means I'm actually have to put it in standard form first, I think. Do you agree with that so far?
Yeah.
So then I'm going to FOIL this part out. And I still have that negative there. So I have negative x squared minus 1x minus 1x is minus 2x plus 1 plus 4. Let's distribute that negative throughout here. Plus 2x minus 1 plus 4. Ew. Plus 2x plus 3. Maybe? Ew. Any idea how to factor this? Let's think. So I have an x and an x, but I'm going to make one of them negative. What's making one of them negative? Yeah, because if I go x times negative x, I get negative x squared, right? Okay. It looks like 3 is my magical number. So maybe put a positive 3 here and a positive, no, a negative 1 maybe there. I don't know.
Yeah.
Does that work? Let's see. That's going to work. That'll give me negative x squared. That's going to give me 3x. That's going to give me positive 1x. Oh, that gets to 4x. Ew. What about this? What if this was x plus 1 and negative x plus 3? Let's see if that works. X times negative x squared, plus 3x, minus 1x, plus 3. Hey, is that the factored version?
Yeah.
Oh, cool. So this right here is my factored form. Okay? That's the factored form. That's kind of nasty, though. If it's in factored form, can I find my x-intercepts? Yeah, heck yeah. So I'm going to take that, set it equal to 0. So I get x equals negative 1. So I get negative 1. That's a comma, 0. Let me clean up that comma for you. Must have fallen off that ladder. It's a little further than I thought this weekend. And then, negative x plus 3 equals 0. Hang on. Subtract 3. I get that. So what's x have to equal? Negative x equals negative 3, so x equals positive 3. I like it. So I got my roots. So find the x-intercepts. We got them because we put it in factored form. Find the vertex? Wasn't the original put in vertex form?
Yeah.
So what's my vertex have to be? It comes off of this and this. So what's my vertex?
1.
1 comma 4. Cool. Okay. And then find the y-intercept. Let's see. Find the y-intercept. What did we have to plug in? Get that? 0. So I can plug it into any of my problems. So maybe here. 0 minus 1 is negative 1. Agree? Negative 1 squared is 1. And I have a negative outside, so I get negative 1 plus 4. So there's my vertex, 0, comma 3. Or my y-intercept, 0, comma 3. So there's all kinds of different stuff up here. All right, flip to the backside. And we are going to take this problem and we're going to complete the square. Okay? On the back, yeah. So let's complete the square. So what form is this one in right now?
No, standard.
Standard? Okay. So we want to go from standard to vertex. Okay. So my A value is 1. So I don't have to divide everything by it. Right? What was the big next spot? Make a space. Everyone see the space there? Okay. So this is going to work out nicely. So it's x. This sign here is always going to come down. So what is half of 8?
4.
What is 4 squared? 16. If I add 16, I also subtract 16. So this right here is a perfect square trinomial, which means, oops, I forgot one thing here. That should be squared. So that, oops, come on, baby. So if I were to multiply this out, if I FOILed this out or double distribute, I get above in the yellow. But then I also have some combination to do. So what's negative 2 minus 16? Can you tell me my vertex? Negative 4 and?
18.
Negative 18. Opposite sign inside if it's grouped, same side outside. So that was completing the square like that. You still have room on their back? Can I move on? Let's try one more. Can we do that? Can we do it? Yes. All right, let's see if we can make something up that's makes kids that don't have me cry. Let's say we had that. So what was my very first step if I were to go from standard form to vertex form on this?
Don't you divide?
Divide by 4. What also gets divided by 4, which is like totally new concept?
Y.
The y, right? So I'm going to divide all of my terms by the 4, including the y. And remember, I got to remember that 4 with this y for much later. So I reduce here. That's x squared. Agree? This is going to give me 4x. And that's going to give me 5. Everybody okay with that so far? Is your 4 being divided, or is your y being divided by 4? Yes. Yeah. We'll take care of that at the very end. What's my next step? Make space. Good.
Make a space.
Making a space. Can you all see the space?
Yeah.
Cool. So I'm also going to write this. Okay, it's going to be x plus
4.
half of 4,
2.
2 squared,
4.
4. If I add 4, I also
Minus 4.
subtract 4. Okay, so this part right here is my perfect square trinomial. So if I were to multiply this out, because I have x plus 2 and x plus 2, if I multiply that out, I'd wind up with x squared plus 4x plus 4. And then there was one last thing. What if I combine those together, what do I get? 1. Okay, I'm so close to being done with this problem, but there's one last thing that I don't want to forget. What don't I want to forget? The 4 under the y. So that's y over 4. So that's division, right? So what undoes division? Okay, so I'm going to multiply this by 4, this by 4, and this by 4. And this is going to lead my answer to be y equals 4, parentheses, x plus 2 squared plus 4. What's my vertex? Almost. Negative 2, comma, 4. This affects my pattern graph. It's not 1, 3, 5. It's 4, 12, 20. Oh, I would totally draw off this graph real quickly, wouldn't it? Okay. So I think we have enough. Ooh, let's try. Do you have a little tiny extra space on there? Let's say I have a vertex of 7, 2. Still with me? And let's say another point that we know on there is 2, 3. Or actually, make that, let's make it 2. Let's make it 4, 3. Is that okay? So you might come to a point where it says, hey, find the equation. So I'm going to go with vertex form, which was this. Okay, so let's find the h and k values first. Where do the h and k values fall? Is it the vertex or is it the other point?
Vertex.
Vertex. So which one's h? 7. Which one's k? 2. Cool. This is just a point, so that has to just be x and y. Now, let's pause. If I know x and y and I know h and k, what letter's missing? A. Agreed? So if I take my x and y and my h and k and I plug it into that vertex form, the basic vertex form, I should be able to solve for A. So let's do that. What's my y value? What did I label y up here?
3.
3. A, I don't know. I need to find. What did I label x?
4.
4 minus, what's my h value?
7.
7. Okay, and it's already negative, so good call on that one. And then that's squared. And then what's my k value?
2.
2. Do I have one unknown up there right now to solve for?
Yes.
Yeah, so let's see if we can figure that out. So let's see. I have a equals a. Let's see. 3 equals a. 4 minus 7 is... 4 minus 7 is?
2.
Negative 3.
Oh, yeah.
Negative 3 squared. Positive 9, because it's grouped. Plus 2. So let's get a by itself. So if I subtract 2 from both sides, we get 1 equals 9a, which is a times 9. How do I get a by itself there?
Divide.
By 9. Ooh, so I get an a value of 1/9. So I know my a value and I know my hk value. So I'm going to take both of those and plug them back into this. Okay, so my a value we just found to be what? 1/9. X minus h, my h value you told me was 7. I got minus 7 there, squared. My k value is 2. So here's my parabola. Here's the equation of my parabola if I was given the vertex and one other point. So you have to use the same equation twice. Use it first time to solve for a, and then you do it a second time. You use it a second time, plugging in your newfound a value and your hk value, leaving x and y alone. Dude. So you have, so last night, or sometime this past weekend, you were given page 83 to work on, and we just went over those problems, right?
Yeah.
Okay, so now we're going to tag on page 84, which is the back side of that page, and page 85. And then, my friends, if you look down at the very bottom of page 85, that's the video to the odd answer. So if you get stuck, go onto YouTube. Go figure it out. Sometimes on YouTube, the number 1 and the letter L, lowercase l, look like the same thing. So if you get to something that says, hey, image not found, or video not found, if you plug it in, maybe change your L to a 1 or your 1 to an L. But this doesn't appear to have any L's in it. We good? Everyone happy?